Hello everyone, this is Satyam. I am going to teach Python. In this video we are going to discuss Python fundamentals. Before starting the lesson, please subscribe my channel and click on bell button. In Python fundamentals, we are going to discuss about identifiers, keywords, data types and typecasting. First we discuss about the identifiers. Identifier, nothing but it is a name. It is a name of the memory location. That means it is a variable name, it is a class name or a function name. But actually identifier nothing but a word, a single word. That any alphabet characters, for example, I can write e name, that is employee name. This e name is a word. S name, student name I want to write. ST name, student name. It is a single word. It is an identifier to identify the student name. And a salary, I want to write a salary. Salary is a word. It is a word. It is also an identifier. Roll number is an identifier. These are the single words we can use as an identifiers. So to write these words, we have to follow some rules. And this is the first one. To write the identifier, we can use small alphabets or a capital alphabet, A to Z, any character we can use. And also the digits also we can include into them. Those digits 0 to 9 and its combinations also, but these digits we should not use at the first position. We can use in that word in middle or at the end or anywhere you can use, but not in the first position. The first position must be the alphabet, a small a to z or capital A to Z. And also in that word, in that identifier, we should not use any special characters except the underscore. Only underscore is accepted, but not any other special characters. For example, here e name, we are writing e name. Yeah, this is a single word. All are the alphabet. ST name also are all the alphabets accepted. This also accepted. And salary, all are the alphabets. Yes, accepted. Roll number, all are the alphabets. We can accept. But we are telling that we can include the numbers also. For example, I want to write name 1. First, I want to write here name 1. Yes, name 1. Or I want to write A123. A123, and I want to write 123 AB. These are also words. This is a word. This is a word. So we can use as an identifier. This is also a word in English. There is no meaning. Don't think about the meaning. 123 AB. This is also a word. This is also a word. This is also a word. But here it is following the rule. The first letter should be alphabet. In remaining letters, either it may be alphabet or digit, but not the special characters. No spaces, no other any special characters except underscore. Here also same, it is also following. A is the first letter, remaining are the digits. Okay, we can use. But here this word started with number, so we can't use this as an identifier. And I want to write some employee salary. Employee salary I want to write. Here I can write EMP salary. EMP salary. This I want to use as an identifier. But we are thinking this is a single word. Then the Python can think these are the two words. This is not the single word because we are giving some space here. EMP salary. When we are giving here special space, special character, it is a special character, so it is not accepted. But when it will be accepted, if you write here underscore EMP underscore salary, now it is accepted. Now it is accepted. If you are not writing this underscore, if you write any plus symbol, not accepted. If you are writing any minus symbol, not accepted. Then only this underscore is accepted. These are the identifier rules, and some rules are there. One more. These identifiers are case sensitive. Identifiers are case sensitive. Means if I am writing here e name, that is a one variable, I want to write a one more identifier, that is e name. E name with the capital letters. Now this is a one more identifier. I am thinking yes, Python is also accept this in another identifier. This e name and this e name both are not equal. This is another one, this is another one. So Python is a case sensitive. Python is a case sensitive. That case sensitive means total is a variable, total is another variable. These both are different. How much length? Here one more point is there here. How much length? Here see 1 2 3 4 5 6 7 8 9 10. How many characters we can use in this? How many characters we can use? And 10 characters are there. Only 10 is the limit. Or if you see here, 1 2 1 2 3 4 5 6, 6 characters we use. How much length we can use this? There is no limit for the length. There is no limit for the length. Can I use like this? A1 1 1 1 1 1 1 1 1 1 1 like this 1 1 1 1 1. I want to use again 2 2 2 2. Is correct or wrong? Yes, it is correct because it is a single word. It is single word and also started with the alphabet. Yes, it is accepted. But the length, there is no limit for the length, even though it is recommended to use the short length. It's a better use of the identifier if you use a short length. This is about the identifier. So briefly think about identifiers are the words, English words, and these identifier follows some rules. Those are, we can use the identifiers small letters or capital letters and digits, and including these three, small letters, capital letters and digits. And these digits should not be in the first position, and in another any positions we can use as a digits. Not only one digit, the combinations of the digits also we can use. And we should not use special characters except the underscore. Special characters nothing but plus, minus, or star symbol, or spaces, white spaces, or tab, like that dollar symbol. These symbols are not accepted. Only underscore is accepted. Here we are giving some examples. So C underscore 20 is correct. C dollar symbol A is equal to 20 is incorrect. Total 1 2 3 is accepted. 1 2 3 total is not accepted. Okay, these are the rules. Then next case, it is a case sensitive. Identifiers are the case sensitive. and there is no limit for the uh, write the identifiers. Remember that identifiers are used to identify something. What is that something? We will discuss further. So first of all, identifiers are the are used to identify something. Next topic, we are going to discuss about the keywords. Keywords are already reserved words. They have a special task. Each word can perform its own task, the task already given. These all the keywords are small letters except only 3 keywords, and also they are only the alphabets. So they are not including digits, numerical values. These 3 keywords, true, false and none, these 3 keywords starts with the capital letters, but remaining all the keywords are starts with the small letters only. Yeah, remember that all the keywords have some special task. We should not assign a external task to those keywords. See, these 33 keywords are these false, none, true, and as, assert, async, await, like that. Here all these keywords, the 33 keywords have their own task. These keywords we should not use as identifiers. The identifiers are given by the programmer, but the keywords are given by the Python. So these keywords we should not use as an identifiers. But remember these 3, false, none and true, these 3 keywords starts with the capital letters. Remaining all the keywords small letters only. Don't include the numerical values also. Okay, this is about the keywords. Each keyword and its task we are going to discuss while writing the program. In another languages we saw that switch and do while, but in the Python there is no switch and do while keywords, and also some primitives also not available in as a keyword. See here, there is no int, there is no float. This key in the keywords list we don't have this int and float, but we have the primitives in the Python. Primitive type values we have. This if you want to get keywords in Python program, you can use this. Okay, right, we will see one by one how to use those keywords and what are those tasks. Yeah, the next topic we are going to discuss about the data types. Based on the given value, the type is considered in the Python, but one thing is we have to understand what is a type of the data. So here data nothing but whatever we are typing we can call as a data. Yeah, by using the keyword we can type something, we can but here the data is divided into some like this. First one, we can give alphabets. We can give alphabets, some capital A to Z, and we can give some values 0 to 9, 0 to 9, and small a to small z, and some special characters, comma, plus, minus, and some brackets, and some square brackets and round brackets, and whatever we have on the keyboard, these things. But here see, we call this is a characters. These are the numerical values we are giving, numerical values. Okay, and what do we call this? What we call this? These are also comes under these characters. Okay, and also some other type of data also we have. Those are the some records we want to store. Where we can store the records? In the file type data, the file, and some binary data we can take, binary data, and that such as images, videos, audios. These are the binary data. So whatever here, whatever the type whatever the type data you want to store, that we can call as here data type. So you want to store character type data, or you want to store numerical type data, or you want to store binary type data, or you want to store some files records type data, or whatever the type that is known as here data type. So but here we need not to mention which type of data you are going to store. For example, I want to store numerical data in some memory location. Yeah, already we discussed that here we have some type of data that I want to store in a memory location. This is a memory location. For this memory location, I want to give some value in it. That value is 1 0 0. This is a numerical value. This numerical value I want to store in this. I think this is the memory location. Yes, I am giving that a 1 0 0. Now we call this 1 0 0 is an integer type. As a human being, we understand this is an integer. Then the Python can reserve some memory to store this value in it. Python can reserve some memory. Python can reserve some memory to store this value. It can store this value in this memory location. But we need not to mention before storing the value. We need not to mention here which type of memory this is. Directly you can store the value. If you are giving a numerical type data such as integer type data, then the memory will store the integer type data. If you are giving some name, for example, the name computer, you want to store this computer, this data, this is the data we are thinking. This data you want to store in some memory location. Yeah, you know, this is a some other type. It is not a numerical type. It is a some other type of data. This type data you want to store. Then Python can reserve some memory, so which accepts this type. That's we are thinking here characters. So it stores the character. We need not to mention yes, I am giving some characters. So reserve the memory for the character. We need not to tell like that. Just the Python can reserve which type of data you are giving, that type of memory location it can reserve. This is known as here dynamically typed programming language. That Python dynamically it can take the type of data into the memory location. Now this based on that given value, the type is automatically considered. If you want to know that type, then we can use the function type function. Remember this function we will do while writing the programming. Okay, right here that means data types. In the data types, the first thing we need to understand, to the Python we need not to tell which type of data you are giving. Just whatever the type you want to store, that type of data you can store it. So actually how many types of data we have in the Python, that we will see here. Built-in types here, Python can accept these types of data. First, integer type data it accepts, float type data, numerical, these two are the numerical type data, and a complex type data. This is the Python specific type data. And Boolean type data, this is a bool type data, and strings, str type, these are the string type. The next list, a list of values, a list type, and a tuple type, and a set type, frozen set type, and a dict type, bytes type, byte array, range, none. These are the different types of are built in the Python. See, one by one we will discuss. First we will discuss about the int type data. Here integer means these are the numerical values without decimal point. These are the numerical values. Numerical values means 1 not only 1, 0. 0 to 9. 0 to 9 and its combinations like 1 to 3, 120 or 1123. Yeah, these are the values. Yes, these are the values. All these values are the combinations of 0 to 9. Yes, these values are known as the int type values. These integer type values are without decimal point values. These values are accepted as a integer type by the Python. To represent the integer values, we can use a int. That Python can automatically identify that is int type. Here there is some small difference for Python 2 and Python 3. We are discussing about the Python 3 only. In Python 3 there is no long type. There is no long type. That means if you are giving this much length of the number, Python can accept, but it accept in int type only, but not in a long type. But Python 2 has a long type, but Python 3 doesn't have such type of long. Only all the values are the integer type only. The long values are also accepted as integer type only. These integers we are understanding. This integers means some of the values, those are only 0 to 9, 0 to 9 and its combinations without decimal point. These are the integer values accepted. Then these integer values we can write in different forms. Integer values in different forms. What are those forms? See, integers we can write in a decimal form, binary form, octal form, and hexadecimal form. In decimal form, the integers are with the base 10. The binary form with the base 2. The octal form base 8. The hexadecimal form base 16. So we will discuss one by one. What the decimal form, how we can represent those in Python. See here, decimal form means these are the with the base 10. These values are 0 to 9 and their combination. Regular numerical values we are using. All those values are the decimal values only. 1, 2, 3, 4, 5, 6. All these values and 100, 1000, 10,000, 1, 10,002, 999. All these values are base 10 values only. So we can take all these values are decimal values. Yeah, the next one is a binary form. In Python, the binary values are prefixed with small 0b, small b, that is 0b or 0 capital B. Those values we can write here. See, this 0 B and only 2 digits, 0 1 0 1 0 1. We know that 1 1 1. It is a binary number. It is a binary number. And 0 capital B. 0 capital B is a prefix. 0 capital B is a prefix. And then we write 1010. 1010 is a binary number. Binary number. It is a binary integer. It's a binary integer prefixed with 0b. Here is also 111 is a binary number. It prefixed with 0b. Then only Python can identify this is the binary number. So if you are not writing the 0b, if you write 10101, then Python can identify this is the 1101. But it is not a 1101. It is a 10101. This is the binary form. If you want to mention to the Python, then you write here 0b as a prefix. then this will become binary integer, binary form of the integer. Okay, that is its a value, that's a base is you know that that is a 2. We write like this: a is equal to, a is an identifier that can identify this integer value. That integer value in binary form, 0b is the prefix, the actual number is 0 1 0 0 1 0 1. This type is also considered as binary form, that is a int type only. The Python can identify this is an int type. This binary form value we can give to the Python, but Python internally converts that value into the integer only. That means integer means a decimal base. That decimal base, it converts into the decimal base and it stores in decimal base only. If you store like this, then if you want to retrieve that value, you will get a 15. That 1111 0b 1111 is the value a, that is 15 only. Means it converts into the decimal base value and stores. And if you want to retrieve, then you will get the decimal base value only, but not in the binary form. Next one is a octal form. Octal values 0 to 7, completely 8 values, 0 to 8, 0 to 7, sorry, 0 to 7. These 0 to 7 values, complete 8 values, are used in the octal numbers. This octal, its base is 8 and it prefix with 0b, sorry, 0o or 0 capital O, 0o or 0 capital O. We write the values here like this. Just to remove. For example, I want to write a number 0. This is 0 O, 0 O. Here 7 5 4. Yeah, this here, this is the prefix. This is the prefix. The remaining is a octal number. Its base is 8. 7 5 4. Yes, these are within the range 0 to 7 or not? Yes, 0 to 7 digits. So it is accepted as a octal integer, octal form. Then one more value we can write 0 O, 0 O. This is 0, this is O. This is 0, this is 0. This is O. 0 O, this is the prefix. Then I want to write here 7 789. 789. See here, is it the base 8 or not? See here, 8 and 9. These 8 and 9, these are not in the range 0 to 7. So it is not a octal form. It is not in octal form. The octal form digits are in 0 to 7 only. Like that we can write a is equal to 0 O 1 2 3. If you get print, then you will get its decimal base only. Whatever you gave in the octal form to the Python internally it converts into the decimal base only. You will it gives the output as a decimal base only, but not in the octal form until you convert it. The next one is the hexadecimal values. The hexadecimal values are 0 to 9 and also A to F, small or capital anything. 0 to 9, these are the 10, and A to F, these are the 5. See, small a or capital A, 10. Small b or capital B, 11. Its value is 11. Then next 12. The D, 13. E, 14. F, 14. 15. That means these values, the range of the values, the range of the values 0 to 9, 0 to 9, and completely the hexadecimal means its base is 16. Up to 0 to 9 we have 10 values, and more A, B, C, D, E, F. These are 6 letters we can use instead of that. This A means 10, B means 11, E means 12, D means 13, E means 14, F means 15. These are the complete. These are the range of the hexadecimal values. How we can write these hexadecimal values? It's a prefix with 0, x, small x or capital X, 0x, and then we can write the digits 17a. 17a. Is it accepted? See here, ox is the prefix. Keep it aside. Then now 17a. 17 is in the range. Yes. A is also is in the range. Yes. That means it accepted. Can I write here 0 x b e r beer? Python cannot accept beer. Python cannot accept beer because R is not in the range. This. But can I write 0 x b e f b e f? If you want to write 1 2 3 b e f 1 2 3, yes, it accepted because these values in the range. These are known as hexadecimal values. Hexadecimal values are prefixed with 0x. This also this see here 0x abc, 0x bef is valid but not a beer. These we are giving the input as hexadecimal values, but the Python internally converts it into the decimal form only. These are the 4 forms of the integer values. In either way you can give the integer values to the Python. Base conversions. Here base conversions nothing but one form to another form. Binary form, octal form, hexadecimal form to decimal form you want to convert, or decimal form, octal form, hexadecimal to binary form, like that. One form to another form we can convert. See how we can convert these things we will discuss slowly. See here, first converting to decimal values. Python internally converts into the decimal form only. Whatever other forms you give, but the Python internally it do its task to convert into the decimal. The programmer is not required any explicitly required write the code to convert into the decimal form. Python internally it will do that. Now see, for example, if you are giving the input a is equal to 0b, a is equal to 0b 1111. This is the binary form. This is the binary form. If you give that stores in a is an identifier here, that a can hold the value of this binary. That binary form will be converted into the integer decimal form. That decimal form, if you want to retrieve that value a, then it returns 15. That means here 15 is the decimal form of 1111. Then in the same way, if you give in the octal form, b is equal to 0017. So b is equal to 0017. It is octal form, but it converts into the decimal form. If you print that, you will get 15. Yeah, we will see this. See, for example, here if you want to store a is equal to 0 b 1111. See, 0b means it is a prefix, 1111, the binary form. It accepted that. If you print a, then you will get 15. For example, b is equal to 0 o 17. 0 o 17 is the octal form. 0 O means octal form, it accepted. If you get to print B, then you will get 15. But 15 is a decimal form. 15 is a decimal form. For example, in the hexadecimal form we can give C is equal to 0 x f. F is the 15. That converts into the 15 and it stores in it. Then if you print f, you will get 15. These are the converting to the decimal. In any form you give, it converts into the decimal form. Then converting into the binary form, but Python internally cannot do conversion of the other forms to binary form. So to convert into the binary form, the programmer is the responsible to write a function, that is a bin function. Bin function. For example, the value x we are taking, x is equal to, I can give a 15. So which form it is? A binary form? No. Octal form? No. Hexadecimal form? No. It is a decimal form. Because there is no prefix, any prefix. That x is equal to 15. 15 is a base 10 value. That is accepted. Then now I want to print this 15, the decimal form, to binary form. Then we can use here bin function. The bin function, which value? 15. 15. Bin x. Then see here 0b 1111. This is, for example, I can give this x is equal to 0 o octal form 17. 0017. This is also 15, but it's the octal form. I want to convert this into the binary form. Then we can write bin of x. Bin of x. This octal form value will be converted. 0o is a octal form. This is a 17. This is the octal form value. I want to convert it to the binary value. Bin means it is the binary value. Converting into the binary value. Also we can get here 0b1111. The next hexadecimal value I can give. Hexadecimal value x is equal to 0x f. 0xf. Right. Now it accepted. I want to convert this value also into the binary form. Then write this 0b1111. That means here decimal form, octal form, and hexadecimal form converting into the binary. Form. This is the converting to the binary. The same way to convert into the octal form. Convert into the octal form, we can use a function oct. Function. It converts into the octal form from other forms. Then in the same way we can use one more function to convert into the hexadecimal. The hexadecimal function hex, H-E-X, hex function. See here in the decimal form we gave, you convert into the hexadecimal. In the binary form we are giving, convert into the hexadecimal, and octal value we are giving, converting into the hexadecimal. This here we have different forms. First is a decimal form. This decimal form base is 10. This is the base is the 10. So conversion to convert into the conversion. To convert into this decimal form, no need to perform anything. The next one is a binary. That base is 2. Then to convert into the binary, then we can use the function bin. The next one is the octal. O-C-T-A-L. Octal. Here the base is 8. The function is OCT. function is OCT. Then next hexadecimal, we have hexadecimal also. Hexadecimal, its base is 16. To convert into the hexadecimal, we can use a hex function. Hex function. Hex function. Yeah, these are the integer type different forms. See here, there are the different forms. Now, so all these values we are giving. For example, I want to store a is equal to 10. Now it accepted a is equal to 10. I want to know the type of that value. Then we can use a function type of a. See here, it is a int type. Then I can give here b is equal to 0b 1010. 0b1010. This is the binary form integer, but Python accepts as a integer type. I want to know the type of b. Any type, not only the 0b, here you give 0x or 0o or any type, any form. That forms are accepted as an int type only. To know the type of that value, then we can use type function. Next data type is float type data. To represent the floating point values, we use float type data. Floating type values. The floating type values nothing but the point values. For example, 12.23 or 15.00 or 16.50. like that. These type of values we can call as a float type data. Here to know that float type data, we can use type function. Then we will get that float type. This float type data, we can use point type values and fractional values. 5 by 6. 5 by 6 will become something 0 point something value. This is also float type value. And if you want to write exponential values, for example, see 3 into e power 10. 3 into e power 10. Like that, these values. Here, see 3 into e power 10. We write like this: 3 into e power 10. These values are 3, 1.8, e3. These are the float values. But remember that these float values only in a decimal form, but not in a binary form, but not in octal form, but not in hexadecimal form. See here, in the binary form, if you try to write 0b111 dot 0b1010, so don't write like this. Python cannot accept this. And octal form, Python cannot accept, and hexadecimal form, Python cannot accept. Here to represent float values, we use only the decimal values before the point and after the point values also. But here to represent the big values in the less place, like this big value, because e into 3 power 10, 3 into 10 power 10, 3 into 10 power 10, we can write simply this is 3 e 10. So that means to represent that big values in a small space, then we can use this scientific notation values. See the example. For example, if we can write f is equal to 12.98, 12.98, we know the type of the f, then it is a float type. For example, we can write some other value, then identifier is a value is equal to, 5 e 5 5e5, then it's accepted. Then get that value. See, 5 5 5 zeros, 5 into 10 power 5, 0.0. This is the float type value. See, you see the type of the value, float type. These are the float type values. To represent the float type values, we can use this decimal point values are the float type values. Next is bool type value. Bool type. So bool type nothing but here boolean data type values. These represents the logical values. These are the true and false. The boolean type values are only two. Those are true and false. These true and false starts with the capital letters only. So don't use this all small letters. All small letters in a true and false, it is not allowed. But Python accepts here true as a 1 and false as 0. Right, we can show this. For example, if you want to store the value in b is equal something true, then it accepts that. Which type it is? If you want to know that type b, here this is so here bool type values, only two values are there, that is the 0 and 1. Okay, so this true means 1 and false means 0. True means 1 and false means 0. So we can see this here. True a is equal to true. Not accepted. Why? See here, t is a small letter. When we are using a small letter, then it will not accept. For example, see here, a is equal to capital T ROE. True, yes, accept. B is equal to, also we can write true. Write a plus b. The true means 1, b is also true means 1. Then it gives the answer 2a plus b. Like that. This is about the boolean values. On these boolean values, we can perform addition, subtraction, and multiplication also. Okay, this is about the bool type value. The next one is a complex type. Complex numbers, nothing but we have imaginary part and also the real part. See, we write 3 plus 4i. In this 3 is the real part, 4i is the imaginary part. Here we are using the I, but Python will accept j only, not I, j. This is imaginary part, and this 3 is a real part. This is the real part. This is the imaginary part. Imaginary. Right. These type of values we can store using the Python, and also we can perform different tasks. See, in the Python, this 30 is the real part, 49 is the imaginary part. This is a valid, it is also valid, it is also valid, it is also valid. What is the difference? See, it's a decimal, that is of int type, it is also int type. It's a float type, int type. This is a int type, it's a float type. See, once remember that this real part must be the decimal, not only the decimal, octal, binary or hexadecimal values, but imaginary part should be in the decimal form only. So these arithmetic, all the arithmetic operations also we can perform on these values. See here, for example, complex numbers, C is equal to 8 plus 7j. So see the type of a C. Type of a C is a complex type. Now D is equal to, I can write D is equal to 6 plus 5j. 6 plus 5j. So if you want to get addition of these two, C plus D. 14 plus 12. Both will be added. Okay. These are the complex type data. This complex type of data, for example, see here, we can write here again, C is equal 1010 is a binary type. No, binary type means prefix with 0b. 1010 plus 4j. So double j, wrong, my mistake. Single j. Yeah, it accepted. Means the real part is in the binary form, but the imaginary part in decimal form. Okay, so that we are telling here. See, imaginary, that real part and imaginary part both will be in the decimal form. Python can convert into that. For example, D is equal to 0x B E f plus 13j. Yeah, it accepts. The real part is in the hexadecimal form, then imaginary part is in decimal form. It accepts. Then if you print B, then you will get that value. Like that, imaginary part must be in decimal form, but real part may be in decimal form or octal form or binary form or hexadecimal form, whatever you can use. This is about the complex type data. The next one is a string type data, str. Here str means here string. What is the meaning of string? We see what is a string. See here, a group of characters we can call as a string, but in Python, whatever group of characters are a single character within the single quote, otherwise within the double quotes, we can call it as a string. For example, within the single quotes I write ABC. It is a string. This is a string. Its type is str type. For example, if I write here X, Y and Z in the double quotes, yes, it is also a string. It is also str type. If I write like this in the single quote, 1, 2, 3, single quotes close. Now it is in the single quotes or not? Yes, it is in the single quote. Whenever it is in the single quote, it is str. It is str type. So can I write then in the double quotes? In the double quotes, plus asterisk bracket and double quotes close. Then what about this is? It's in the double quotes or not? Whatever in it, so we don't know that. We don't care about that. Is it in the single quote or in double quotes? That's enough. Then it will become str type. Okay, this is the string type, means a group of characters. Here character nothing but whatever you are typing, that is a character that enclosed within the single quotes or in the double quotes, that we can call as a string type data. See, we will see here. For example, S is equal to, in the single quote I am writing ABC, single quotes close. S is equal of S. See, str type. In the double quotes, yeah, we can write S1 is equal to. Can I write S1? Yes. 1 yes? No. 1 yes we don't write. S1 only. S1 in the double quotes. The double quotes. This is Python. This is a Python I am writing. Yes, it accepts. See the type of S1. Type of S1. It's a str type. A string type. Okay, S1. If you want to print S1, this is the Python we can get. This whatever we are writing in the single quotes or double quotes, that is known as a string. But the single quote is always recommended. Just we are thinking that just it is recommended for the single quotes. In a Python, there is no character type data. So whatever you want to include in this double quotes. So, for example, I want to write only capital A. So a single character, is it a character type? So if I enclose in the single quote, yeah, you are enclosing in the single quote with a single character is also a string type. Python does not have character type. It is also str string type data. Yeah, this is about the string type data. Right, now we discussed different types of data. Okay, those are the what we discussed. Int type data, float type data, the next bool type data, the next complex type data, next str type data. These 5 types are known as primitive types. Primitive types. Primitive types. Okay, this is so. See this video once again and remember all those points. So I gave you the in PPT also. This PPT will give you the complete information about this type, and we will go in depth in each data type while working in programming, and also we will see some other complex type data also in the next video. Thank you. Please subscribe my channel and click on the bell button.